All right, welcome back everyone. So we're still talking about these sampling distributions, and so let's go ahead and finish up this kind of little bit of note section on them. And so you should still have the StatKey app open. Um, as a reminder, we were working with this pet example where our population proportion is 0.68 because we know that 68% of all families in the US own a pet, and we're looking at the sampling distribution for a sample size of 11. And so in the last video, we had kind of built that up. So let's kind of wrap up some ideas from that. And so keep in mind that what we actually needed to construct that sampling distribution, well, we needed kind of a few things. We needed n, our sample size. So we needed to know what our sample size was. In this case, it was 11. We needed access to the entire population. And so that's just because we're sampling thousands of times. And the second part is kind of the unrealistic thing. And so I'll go ahead and number these and just say number 2 is usually unrealistic unless we have a census, which we did for this example. That's why we were able to build up the sampling distribution, because we had a census of the entire United States households. All right, and so things to kind of think about in relation to sampling variability, which we discussed a couple videos ago, is that we're kind of getting these different sample proportions. And so we're eventually going to have a measure of how the sample proportions tend to vary from one sample to the next. But in this example, it's actually not even possible for the sample proportion to be exactly equal to the population proportion. So remember, the population proportion was 0.68. Because we have the sample size of 11, it's impossible for our sample proportion to kind of exactly match the population proportion. And so for this question, something like no, it's actually impossible for our sample proportion to be 0.68 in this example. Okay. So we could look at kind of a few things about our sampling distribution now that we've built it up. In particular, we want to look at the mean, we want to look at the shape, and we want to look at what the standard deviation is. And so that's all stuff that we've talked about before. The shape, you could kind of see it's like slightly left skewed here because it's got that longer left tail. And so if I were to answer this question, I would say no, it doesn't really look approximately normal because it has this slight left skew. The app also gives us what the mean of our sampling distribution is, and so that's up here where it's telling us that the mean is 0.676. If you were following along because of the randomness of the kind of resampling, your mean might be slightly different. But no matter what, it should be close to the population proportion, 0.68. And so that's kind of an important trait, and that should make some intuitive sense that if you were to do this resampling and continually calculate sample proportions, that they would be centered around what the actual proportion of families who own pets in the US is. It also gives the standard deviation, and it calls it something that we haven't talked about yet, but this 0.141 is the standard deviation of this distribution. You should kind of be able to guess that that at least makes sense based on the practice that we had guessing standard deviations from histograms. A standard deviation of 0.14 seems like it would be about right based on the earlier practice we did. So our standard deviation is 0.141. Okay, so the last thing that we'll do is just investigate how the shape changes as we increase our sample size. And so what if we were to, instead of repeatedly take samples of 11 families, what if we were to sample 20 families and do that thousands and thousands of times? What would change about our sampling distribution? So we'll kind of see, does the shape change? Does the center change? Does the spread change? And so we're going to look at all three of those things. You should be able to kind of just mess around and investigate, slowly increasing the sample size until you think that the sampling distribution is approximately normal. And so I just tried 15. It still has the slight left skew, so I'm going to give that a thumbs down. That's going to be a no from me, dog, and we're going to increase it a little bit more. That looks a lot more normally distributed. It's definitely a subjective judgment call at this point, but it does still have the slight left skew, so I'm going to up it a little bit more to 25. And 25 still to me has that slight left skew, so I'm going to up it one more time. I'm tired of upping it, so I'm going to go higher to up to 32. And then that to me looks a lot more normally distributed. And so the tails are about the same, so I'm going to give it a thumbs up for 32. Again, it's subjective. So you could definitely come up with a different number and totally be fine. And so 32, but we'll kind of make a note that but this is subjective. So whatever you decided on, keep that and note what your mean of your sampling distribution is. Mine is, in this case, 0.68 exactly, and so I'll make a note of that here. And is it different than when we had a sample size of 11? Barely. So is it different? Yes. Yes, but only very slightly different. Alright, so far it looks like when we upped the sample size, the shape changed because it's no longer slightly left skewed, it's approximately normal. The center didn't really change. I mean, it changed just a tiny bit, but barely anything. The spread, my standard deviation is 0.081 now. And so the shape changed, the center didn't change, but as we're kind of investigating, we're seeing that the spread 0.081 does change. So yes, it is smaller now for the n equals 32. And so this will end up being really important. So this fact that if we increase our sample size, that the sampling distribution kind of gets squished together and the spread or standard deviation gets smaller as our sample size goes up. This will help explain kind of why having a larger sample size usually is a good thing. Okay, so we're gonna jump off of StatKey for the rest of this note packet, and so as always, definitely let me know if you have any questions. You'll get some more practice with this on the handout, and so hoping things will just get more and more clear. I know this is a tough subject to talk about, just because of how kind of abstract it is, but we're trying to ground it as much as possible, and I think the more practice, as with most things, the better. So yeah, definitely let me know if you have any questions, and have a great night, afternoon, morning, evening, whatever time of day you're watching.